question 17. This one states the set of points is a circle. I mean the set of points these right here from the basically x, y, z. In other words, in three dimensions of x squared plus y squared equals 1 is a circle. And this is actually false because again there's a z component there that is assumed because this is in 3D. So in other words, for every point here, you're going to have an infinite amount. So if this is actually an equation of a circle there, but it's in 3D. So in other words, you're going to have a vertical component. You're going to have I'll draw this actually. It's going to look like this. It's going to be circle in the XY plane, and then you have the vertical Z component for every single point. So in other words, we have a cylinder, a circular cylinder. So solution false. This is false. The equation represents a circular cylinder. Is my thumbnail of my earlier video in the link. So if we have x squared plus y squared equals 1 in 3 dimensions, that is a cylinder. And here's a horizontal one: y squared plus z squared equals 1. That's horizontal. So we can also graph the cylinder in GeoGebra. Just to double check that using their 3D graphing calculator. So you type in, just put in x squared plus y squared equals 1, and we get a cylinder. I just wanted to put that in there so you can double check and so on. So we got that. All right. So now let's take a look at question 18, and this one states in R3. Actually I had to look up this one here and compare what difference between this R3 and V3 that I've been covering before, such as this one right here. So I looked it up, and basically V3 is just a more general set of any points, just with the three set of points, or just a more general any set of 3 points and so on. But then R3 right here, this R3, this is just this is the set of all real points or real numbers, or just set of 3 points that are all real numbers, and this is in 3D geometry and so on. The specific definitions is for another video in the future. But anyways, it's basically we're doing 3 dimensions, real numbers. That's all I'll get into. So in R3, the graph of y equals x squared is a paraboloid. It's saying, so in 3 dimensions, this graph right here, y equals x squared, is it a paraboloid? And again, this is not a paraboloid because if you draw it in the y and x components set up there, because if you're doing it in 3D, so if this is the x, this is the y, you're going to have a parabola that opens up like this. It's going to open up like this. So the y is parabolic, and the x is just the linear one going here, and then you square it. So in other words, that's their function. But then again, we have the z component, so this is going to be a parabolic cylinder, not a paraboloid. It's just a basic cylinder, and so the solution, this is false. This is false. The graph y equals x squared in 3 dimensions. It represents a parabolic cylinder. Is linked to my earlier video. So z equals x squared. This is the vertical one. But in our case, y equals x squared. So graphing in GeoGebra, we can see that the equation is a horizontal parabolic cylinder. And right here, just put y equals x squared. We get this horizontal one as I just drew. And note that a paraboloid, that's just it's a shape like this. It's like a bowl. It has a point that it has a actual like bowl shape like that. It goes up and up. Draw it like that. So that is that's an actual paraboloid. This one is just a parabolic cylinder. This just keeps going on to infinity and so on. This one doesn't actually these don't converge into a single point like that. So that is the paraboloid, but this is not a paraboloid. This is a parabolic cylinder.